Welcome back. This is Professor Waits, and we're looking at Chapter 13. In this video, we're going to start at Section 4, and we've already talked about this a little bit. Why do we have private members? But the chapter is going to discuss a little bit as well, and so let's jump in and just talk through some of these points. So remember, we've already talked about public and private, and we talked about how this creates certain levels of access to your members. So one of the main reasons to have the availability to make items private is through is to create data protection. We've talked a little bit about this. One of the examples we gave was passwords. We want to have a class that we make into an object that allows us to insert the password into the object, but we don't want to allow it to get back out. So there's one way to create data protection. Another way is, let's say when you start up a new object, when you instantiate a new instance of an object, there are certain parameters that should be set at start and then never be changed. Well, we can do that with the use of private members. Again, one of the things we're always trying to do when we're programming is, how do we keep our code safe? How do we keep our data safe? And one of the best ways is to make it to where it can't be changed, that the program itself can't change it. And with that, we can then give some certainty and some guarantee to the fact that our data will be exactly like we want it to be in a good state. Oftentimes people talk about data as, data coming in that's bad means data going out is bad as well. And I know that they typically say it's in a much more vulgar manner, kind of that crap in, crap out kind of thing. But you get what I'm saying is, once the data is corrupt, it can't be fixed. So that's why we always talk about data protection. So with that, we can make use of public functions to reach those private items that we want to allow to be changed, or we want to allow to get. Again, we've talked about setting variables through functions, public functions, but not being able to get data. Well, we can do this the other way around. Is we can have data that's been set. Let's say when you start up a new object, you go ahead and through the starting up of that object, you set certain variables in the startup. And you can no longer change them once it's been started up. So we won't make any functions, any public functions that have the ability to change the vars, but we can have public functions that give you the data back. So there's a good example of kind of that read-only data. We set it the first time, and then from there on out, it can't be changed. We also talked about the fact that we want to avoid data being stale. Well, again, through public functions, we can allow data to come in, and we can go ahead and perform any mathematical functions we need to on private members. So that way, the data inside the object always stays up to speed. So this is just a kind of a representation of how we have these private items, and the only way you're able to access them is through these public methods. Now again, if we decided to, we could get rid of, let's say, the set, and so that way we would expect that somewhere else in the code, these, usually on the instantiation of the object, these variables are getting set. And now all you can do is get. You can't, because remember I was saying we got rid of the sets. Now you can only get. So again, we've now made these more secure, and we don't have to worry about them getting changed midstream. So let's talk a little bit about separating specification from implementation. We talked a little bit already. I gave you a little bit of a clue earlier in one of the previous videos. I believe it was video 1, about when we start declaring our class, we can put that declaration in a header file. And we know it's a header file because we got the .h out there. Then we actually put the definitions in the CPP file. And we also need to make sure that we include the class specification file. So this guy up here. So programs that use the class must also include that specification file, or known as that header file, right? And we'll see some examples of this. Now let's talk a little bit about inline member functions. The member functions can be defined inline, which is in the class declaration, or after the class declaration. So here's a good example of how we can do an inline to describe a short function. So this is inline. You've got your standard pieces here. We even put the constant out there saying that we're not going to change data inside the function. We go ahead and give our brackets and then do a short piece of code. Now remember, for inline, typically when we're doing inline, there's either a very special reason to do inline, or the function itself is going to be very short. Most inline functions you would expect to be short. In fact, if an inline is going to be really long, oftentimes the function will be written, another function will be written somewhere. So we'll have a function out here that's whatever, and then we have our other function up here that has the inline, and we'll actually just go ahead and call this function. So that way we keep this inline short. Again, you're probably going, well, why would we do that? Then just don't do the inline, just do, a standard member. And yes, like I said, most of the time that's how we would do it. But there are times where an inline, just for maintenance and aesthetics, would look better, would work better. And so, like I said, but it's going to be too long, so we'll do the process I just talked about. But the real focus, again, is to make sure you're focusing on the fact that we have the ability to create these inline functions. And here is an example. So what would that look like in an actual program? But before we jump into that, let's make sure we notate a few things here. So we've got a class, right? One of the things that when you start creating header files, you're going to start doing these lines of code to make sure you don't try to do it twice. You don't try to read this definition or this what this class looks like in twice. So you'll start using these in if not defined, and then define, and then the next line. It's on the same page, and we finish it up with that indif. So if not defined, rectangular H, then we're going to define it, and then we have the indif. Now, the actual function itself, we've got private and we've got public. And here, because even though that we're in, now remember, we're in the H file, we're in the specification file. So instead of saying, just this with the semicolon and then down in the class, the CPP file, declaring it, because it's so short, instead we're going to do that inline, and we're going to do it right here in the actual header file. In fact, we do it a couple times. So here are three short inline functions. But the interesting thing is these two are going to still have to be done in the CPP file, because we did not do any declarations, or excuse me, inlines here. So why would we use inline versus regular? What are some of those trade-offs? Well, regular functions, when called, the compiler stores return addresses of calls, allocates memory. There's a whole lot going on behind the scenes. And the interesting part is when we're doing our development, oftentimes our functions aren't that short. So these kind of things don't really come into play. We don't really think about these things. But it is worthwhile to say that if you have, like up here, these one-lined functions, then this should kind of come into your brain about, now we've got compilers making addresses and storing things at certain different places on the memory, and so forth and so on. Code for an inline function, however, is copied into the program in the place of a call. So larger executable programs, but no functional call overhead, hence faster execution. So again, I get a little leery when people start talking about how, oh, well, you do this and it's faster. Yes, it is technically, but we're talking usually nanoseconds at this point. And because the function itself is so small, the function itself is probably only going to run for a few nanoseconds. So, while yes, this is true, when you start getting into the logistics of it all and you start actually programming, and this is not going to be something that's too much on your brain, especially for those very short inline functions. All right, this is a great place to stop. The next part is going to talk about when we start to instantiate objects, how we can kind of make it to where people, whoever's using your class to make an object, that they have to do certain things or not do certain things. So when we come back, we'll be talking about constructors. Thanks, and I look forward to talking to you soon.